The economic advancement and rapid technological modernization has resulted in the initiation of low-cost and improved electronic products in the market, which incredibly increases the volume of electrical and electronic equipments being procured by the consumers. This diminished the sale of used electronic products, resulting in the generation of large quantities of scrap, including computers, televisions, mobile phones, washing machine, etc., which are not fit for their original intended use and are generally termed as e-waste. The quantity of these discarded equipments is increasing with disquieting rate all over the world due to rudimentary disposal, improper collection system, as well as lack of cost-effective technology for processing them. These obsolete devices are made up of a variety of components, some of which are lethal to life, but all of which are valuable resources. Therefore, effective feasible technology with minimum environmental impact is required for the recovery of metals from such scraps. The preeminence of e-waste management is enforcing countries to establish new models for the collection and environmentally sound disposal of e-waste due to the high toxicity of these pollutants, especially when burned or recycled in an uncontrolled way. Recycling is the most efficient and imperative solution to this growing e-waste problem, and it has become a significant economic activity. In India, CSIR National Metallurgical Laboratory is the pioneer in the development of application-oriented e-waste recycling processes fulfilling zero-waste concept. In order to create the infrastructure for electronic waste recycling, NML have various collaborations and sponsorship with national and international research institutes and companies for the development of various methods to recuperate metals from e-waste in an organized manner. To protect the environment and conserve the natural resources as well as energy, scientists at CSIR lab in Jamshedpur have successfully developed viable technologies for the effective recovery of valuables from these obsolete electronic devices. Printed circuit boards, or PCBs, are the major components of almost all electronic equipments, and it constitutes a heterogeneous mixture of organic materials, metals, glass fiber, and epoxy resins. NML, in joint collaboration with Korea Institute of Geosciences and Mineral Resources South Korea, developed an innovative pre-treatment technique for effective recovery of metals from waste PCBs. Initially, the PCBs were crushed and then processed for further recovery, but the encapsulation of epoxy sheets rarely extracts metal. As the physical pre-treatment process is not energy efficient and economical, thus an alternative method of organic swelling to recover copper, lead, and tin from scrap PCBs is developed. This easily liberates the thin layer of copper metal sheet and separate the outer layer of epoxy resin, which mostly contains solder material. This method has been recognized by the Recom industry in South Korea. Apart from this, a novel process to recover copper from waste PCB using the process of pyrolysis and physical beneficiation, followed by leaching, solvent extraction, and electro-winning is also developed at NML. PCBs were pyrolyzed at different atmospheres and were subjected to comminution for the separation of metallic from non-metallic fractions. The metallic concentrate was then leached at optimized condition, which results in complete dissolution of the metals. From the leach liquor, acid and metals can be recovered by the process of solvent extraction using mixer-settler unit. Pure copper metal sheet was obtained by the process of electro-winning. Eco-recycling industry, Mumbai, validated this technology and conferred NML with an appreciation plaque. Another process of extracting gold from used mobile phones, medical equipment, and telecommunication devices have been effectively developed at NML. Almost 350 grams of gold can be recovered from 1000 kg of scrap mobile phone PCBs. Initially, PCBs from the waste mobile phones are removed and further processed using different reactant which can selectively dissolve gold. A technological know-how for gold recovery from scrap mobile phone PCB has been transferred to ADV Metal Combined Private Limited, New Delhi. Another process for gold recuperation from scrap telecommunication and medical equipments is also developed, and the process has been transferred to Eco Recycling Company, Mumbai. In these scrap, gold is generally found to be coated on different base metals like aluminium, copper, iron, etc. It is an innovative method where gold-plated components are leached depending on the composition of the scrap, and pure gold metal is obtained. Now, from PCBs, let's move towards mobile phone batteries, which constitute a major fraction of e-waste. These batteries contain rare and strategic metals such as cobalt, lithium, nickel, etc. that should be recovered in an eco-friendly manner. In this regard, CSIR-NML and ADV Metal Combined Private Limited, New Delhi, worked under joint collaboration. Scrap batteries were beneficiated through a highly energy efficient and industrially viable technique using scutter-crusher and wet scrubbing process to obtain the black powder containing lithium cobalt oxide. The black powder is further treated with suitable lixiviant for the dissolution of metals. The purified solution obtained was used for the recovery of cobalt as salt or metal using crystallization or electro-winning process. ADV Metal Combined Private Limited has expressed satisfaction with the lab scale process. Another hydrometallurgical process to recover salts of neodymium from waste magnet of scrap hard disk of computers is also developed by NML under Indo-Russian collaboration. Hard disk contains NdFeB magnets which are initially crushed and then leached. Using the process of precipitation, neodymium fluoride salt is prepared. The know-how is ready to transfer. Moreover, recycling of fluorescent tubes and LCD panels for the recovery of rare metals such as lanthanum, yttrium, terbium and indium is going on under CSIR-supported activities. Phosphor powder, rich in rare earth metals, is present as a thin layer in the fluorescent tubes, which are collected and processed for rare earth recovery, while the LCD panels containing a layer of indium is initially crushed and then hydrometallurgically treated to recover indium. For any further information, please contact Head Business Development and Monitoring Division, CSIR National Metallurgical Laboratory, Jamshedpur.